Hi, so this is the final presentation today. This is graphics and materials, following up from history of graphics and poly modeling or polygon modeling. This shows you how to create materials using a combination of texture maps. And what we might do is, if you can get tinyurl.com/Porsche render, we'll link to Sketchfab, and you'll get this really great interactive Porsche 911 Turbo in the 70s. Here it is here. It's really nicely done. What I love about this model is that it's really just the bare minimum polys to get a great result. So this is what's known as game ready. This is the ideal sort of format that you want for something like Unreal. So it's it's detailed enough so it looks incredibly impressive up close or at a distance. Even up close you can get things like the tires here, pretty damn great, and like even little wear and tear. It's pretty fantastic. But at even a slight distance, it's really great. It's just pretty amazing to see. So what makes this great? That's what I really want to take apart. And what we're going to look at is we'll flick between it, but each one of these materials here is made up of a series of textures, and we'll go through those now. So if I just jump out of this for a moment. So a PBR, or physically based rendering system, is what Unreal uses, and that's what we'll be using. So a PBR metallicness system has, to create a material, you need a series of texture layers. So you've got an albedo layer, a normal map, a ambient occlusion map, a roughness map, a metallic map, and occasionally we use a height map. It's not very regularly we use a height map. Unreal Engine doesn't support height maps very well, but there are exceptions to the rule, especially when making like ground textures or things for architecture like brick walls. Height maps can be useful, but in general, we will focus on metallic, roughness, ambient occlusion, normal, and albedo. Bump, normal maps, and albedo maps really give you the most bang for your buck. And then on top of that, roughness and metallic, which have in some ways similar but just different enough properties. So if we go back to this Porsche render, what we can see here is if we go to, you can see therefore that's the UV mapping, which is done quite well. And if we go over to the base color, so the base color is otherwise known as a diffuse map or an albedo map, depending on what software you use. But it's basically just like the most basic sort of color. It's like if someone took a photo of a texture and then put it on there, and you can look at that literally looks like it's come off a texture. It's just like no one's taken a photo of the sidewall of a Pirelli tire there and put it on. It doesn't really pop that much by itself. It looks kind of a little bit flat. That's why if you add something like, I believe this is a metallic map here, roughness, you add a roughness map, you add a normal map, ambient occlusion. Cavity map I wouldn't worry so much about. Opacity is really good for glass and that sort of thing. Don't really use specular in our workflow. So I'll go back through that. So metalness generally, so where it's white, it's going to be metal. So obviously the body of the car is metal, and the bolts here are metal. So it'll have certain reflective properties similar to that of metal. Roughness goes from 0 to 1, and grey like this would be, I'd say, about 0.4 or 40%. So as you can see, where you've got a bit of wear and tear, roughness maps really show off the age of an object and really give that sort of sense of entropy, or I think just simply put, wear and tear, something that sort of makes the object look more realistic. Normal maps are otherwise known as bump maps, we went through in class. As you can see here, just the attention to detail is quite phenomenal. Bump maps, in my humble opinion, are one of the best, most bang for your buck. Use a bump map because it will make everything look like it pops without it actually putting that much load on the GPU. So the graphics card we were talking about before in terms of polygon meshes. There's a lot of polygons on a graphics card that you can use, but also, and when we talk about poly meshes, we're talking about heaviness. Something with a lot of polys, say over 10,000, is quite heavy. Something under 10,000 can be considered quite light. When we talk about graphics, we talk about expense. So if you've got a lot of textures, it's considered expensive. If you don't have a lot of textures, it's considered quite quite cheap. So with this, normal maps are a really cheap way of creating that illusion of bump and geometry without actually adding too much to the graphics card. It's really great. Ambient occlusion maps are just shadow maps. They're automatically generated most of the time, and just where you've got divots in an object, it'll just create that. It'll bake in the shadows, so they don't have to render them, and it uses a lot less energy, a lot less of your graphics card. The other maps we won't talk too much about, but we'll get back into it. So if that's not making sense, hopefully the next example will clear things up a little bit more. And again, don't worry too much. Have a look at the other examples in Sketchfab. Just use the numerical keys to go through the different types of maps. I always find looking at other people's work and trying to reverse engineer it and figure out what works and why it works is one of the best ways to learn. So we'll keep going with this. So again, just going through the texture layers, the ones that are really of importance in my humble opinion. So the albedo map and the normal map really make up for about 80% of it. And then on top of that, it's the roughness and metallic maps that you can control. Ambient occlusion generally comes in automatically. Generated automatically, but and things like height maps are rarely used. There are several other maps, opacity maps, emission maps, but these are really specialist type maps that we'll cover in greater detail later on. For what you need to understand for the fundamentals, these are really the core concepts that you need to grasp. So here you see a generator which is pretty low poly, but it's game ready. What I love about this is you can see down here with the wheel that it's pretty janky, but yet it does a really good job of selling this idea of an old Honda generator that's seen better days. And it does that through a series of maps. So the maps, the texture maps, here you go, albedo or diffuse over here. So that's like if you've taken a photo of something and laid it out. Normal map is the bump map, so that's creating like that sort of fake geometry. A good rule of thumb is if it's under 1 millimeter, that's when you use a normal map. If it's over 1 millimeter, that's when you consider using geometry. So ambient occlusion here, which is generally automatically generated, which is a shadow map. So where you see sections in shadow. Roughness is, just where it's white, it's going to be dull and matte sort of finish, and where it's dark, it's going to be quite a shiny, reflective surface. Metallic generally is all white or all black. Things are either metallic or they're not. You don't have varying degrees of metallicness, as we will demonstrate. So again, white is 100% of that thing. So white here, in terms of something like roughness, if something is completely white, that is completely matte surface in the roughness there. With metallic, it's either 0 or 1. So with that, it's 1. So that section there is going to be quite metallic, as you can see there. It corresponds with the metallic surface there, the control panel. And 0% is just black. So getting onto bump maps, here you can see it's a really cheap way. Like, this is a 6-sided square. This is a really cheap way to add what looks like geometry but really isn't. And it'll pick up the shadows, and it'll pick up, if it's got a good ambient occlusion map, which it looks like it does, it'll look like it really pops out of the page, even though it's only a 6-sided polygon. Like I said, bump maps, a really well-executed bump map is the way to go, in my humble opinion, most of the time. UE4 doesn't play nice with complex sort of displacement maps. We've done them in the past, but it just ended up being a bit of a nightmare, so I'd avoid them. You can use height maps in certain circumstances, but first port of call should always be, 9 times out of 10, as they say, it should always be a bump map. So a bump map, what it can do here is you've got a 4 million triangle mesh there. It's super complex, that if you try to bring that to a scene and animate that in real time, you might have a bit of a drama. However, if you simplify the mesh with, say, 500 triangles, which is, I think we figured out in class, 8,000 times less, and then you apply a normal map over the top of that, you should be fine. You've got, so this is the rare case for a height map. So you've got an albedo, which is the diffuse layer, the normal map, which is getting all those nice little cracks there, a roughness map where you can kind of see everything's reasonably rough. But the height map, where I really like this, is that it will pop out, so you can kind of see the geometry pop out. Now, this doesn't always work out perfectly in Unreal. It's a bit of hit and miss. But using parallax mapping is probably the best way to achieve this, in my humble opinion. Again, you've got to see if the juice is worth the squeeze, whether you get the return on investment that you want off doing it. Because it is a little bit of extra work, but sometimes it pays off, where it's like a brick wall or a ground that is pretty repetitive like this. It's really good. For other things, I tend to caution against it. To create seamless, so repetitive materials like this, I'd highly recommend understanding Substance Designer. The best way to go about this is, other than doing the Lynda tutorials, I would actually go to something like Substance Share, where you can get a lot of these files and just open them up in the program and reverse engineer them. Like I said in the past, I have no problems or no qualms with you taking other people's materials and modifying them, as long as you just let me and Dan know when you go throughout the course. Here are some height maps done, I think in Unreal. Look, again, they look great here, but to get to this point might be a lot more work than you think. It's worth giving it a shot though, and these are the times that you use height maps where you can kind of see it pop out of the page. If you use displacement maps with DirectX 11, you are going to have all sorts of dramas, we found. If they have fixed that, then it's worth using by all means, but we found that it just slowed down the whole scene so dramatically that it wasn't. It just chewed up resources. It was both heavy and expensive. So having said all that, when you do get a like the Porsche wheel, as you saw before, and you get it, you want to paint, you know, the Porsche logo here or stamp it or whatnot, and you've got all those perfectly UV mapped, then you can bring them into Substance Painter and play with them. It's a lot of fun. Finishing up here, just something that I want to mention is that, unlike most architectural visualization or product design visualization, or vehicle visualization, Generally, what we're aiming for in a virtual environment is something with entropy, which is something that shows the second law of thermodynamics, or just something that shows off how good objects can look when they've been subjected to a bit of wear and tear. This is super important. I think, like you can see a bit of rust, and you can see like where the paint is chipped away. If you want to create a scene that's believable, that people, when they are in a virtual reality environment or it's projected on a wall, that people don't second guess, you really need to create that sort of patina that it looks like people have actually used it. So often I see in virtual reality environments, everything looks bright, shiny, and new, and it's just really jarring to the eye, because if you go into any office, even look at the floor that you're watching this tutorial on now, chances are there's a few scuff marks, a few scratches, and there's a lot of variance in there, and that's really what you want to do, because your eye picks up on patterns, and if things look too perfect, it's just this it's this unsettling sort of feeling. So when you're doing stuff for the virtual environment, try to add a bit of patina to it. So yeah, I'll play this in class. I'll just mute this for now and just go through them. You can go through this at your own time, but this just explains base color, metallic, roughness, normal, and ambient occlusion. So it's basically you're layering these up. So here's the albedo, the diffuse, the base color, same. And that's like if you took a photo of a wall and it looks pretty muted, so you just want the literal color of the areas in the space. So it's not anything other than just the color. And then when you add, so metallic, because it's not a metallic surface, obviously it's going to be black, but if it was a metallic surface, say like a galvanized wall or something like that, or checker plate or something like that, this would be completely white. As you can see, the metallic just looks very funky on the right there. Roughness. So roughness is it reflects reflectivity of a surface, or how well it absorbs or reflects white light. 0 being very shiny, 1 being very rough. Brick walls tend to be quite rough. There you go. And it's just about layering all these, and I think they put a metallic substance over there, and you can see why it doesn't look too good. This is where I think you get the most bang for buck, is the normals, or otherwise known as the bump map. And this is what really sells the idea of, you can see on the left there, you've got the bump map there, and it really just pops off the page. Height map isn't as useful like in this particular scenario. I don't think it is. Sorry, let's see if we can see it. It's not really as prominent. I don't necessarily think by adding it you get that much out of it, in my humble opinion. There are other circumstances where a height map probably would be more useful, but yeah, it's not really making the case for it. Anyway, yeah, we'll leave that at the moment. Have a look at the tutorials from Linda. Install all the software on your computer and have a bit of a play, and see how you go. Thanks. Bye.